This is part 2 of YouTube's about pointers. In particular, we are going to talk about pointers and arrays. So I'm actually going to kind of do it by example. So here's my first example. I have an array declared here. It's a 2 by 3 array of integers. And the first thing I want to point out is how these things are saved in memory, because you have to understand how an array is saved in memory so that you can use pointers with it to access the array elements. You already know that the address of data, in this case the array is named data, you already know that the address of data is the address of the first element in the array. But let's look at it a little bit more in depth, because I have a 2D array now instead of a 1D array. 1D array was easy to understand, but now we're going to deal with 2D arrays. So first of all, if I were to draw this as a matrix, it would look something like this. So maybe you could call this an array diagram, if you will. So this is element 0. Let me get my highlighter going here. This is element 0, 0. This is row 0, column 1. This is row 0, column 2. I could say this is element 0, 0. This is element 0, 1. This is element 0, 2. And this is because I have 2 rows, 3 columns. This is element row 1, column 0. This is row 1, column 1, and this is row 1, column 2. However, you don't have 2D memory in your computer. You have 1D memory, and everything is sequential. So this is how it's stored. So data element 0, 0, which is the beginning address of the array, that address is the beginning right here, gets 2. And you get the first row. 2, 4, 6 is the first row, followed sequentially by the second row. And so I have each of the indices listed here, and you can see that this is how it's stored in memory. When we write something like this, we can call it kind of a memory allocation diagram. And that's what we're going to do several of here coming up to make sure you understand the 2D arrays and how pointers work with a 2D array. So here's another example that we'll just do. Show the memory allocation for, and there's 2 examples here, 2 different arrays. But notice that I've initialized them kind of strangely. So let's show the memory allocation. So for the data array, there's 8 elements, correct? So I would have data element 0, 0. Let's see, I have, this is rows, this is columns. So I have 1, 2, 3, 4 rows and 2 columns. It looks something like this. Whoops, backwards. 4 rows and 2 columns. If I were to draw it more like a matrice, it would be 4 rows and 2 columns. So element 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, 2, 0, 2, 2. Something like that. Get rid of that for a minute. Okay, so I have a 0, 0, 0, 0, a 0, 1, a 1, 0, a 1, 1, a 2, 0, a 2, 1, and a, oh, did I do that wrong? It's 4. 3, 0, 3, 1. I think I wrote it wrong over here. But I erased it already, so evidence is gone. No, it's preserved forever in video. Or as long as I let it say. But the funky thing here is it says that I'm only initializing it. I'm not initializing it here with 8 values. So what happens when I initialize it this way, where I've only given one thing here? So what's going to happen? I'm going to get only this part initialized with that first element, and then all the other places are just going to get filled in with a 0. So row 1 is this, but row 0 gets this. Row 1, row 2, and row 3 get all zeros. So it was a strange way to initialize that array, but that's exactly what happens. So let's look at this other array, H. H is a 3 by 3 matrix, and it's all zeros. So I would have H 0, 0, and honestly I should have done this completely formally with all these indices, right? So if this were a test question, you would make sure you wrote it correctly the whole way. So this is a 3 by 3, so I have 0, 0, 0, 1, 0, 2, and then I have 1, 0, 1, 1, 1, 2, and then I have 2, 0, 2, 1, and 2, 2. It is a 3 by 3 matrix array of zeros. It looks like this. But what is the memory allocation? It's sequential like this, and everything is filled with zeros. Each memory location addressed by these indices shown here. So that's how these two arrays would be stored in memory, and that's what their memory allocation looks like. So now let's throw in pointers. Now assume that I have an array, an integer array, a y, defined by the following statements, and then I have a pointer to y. So my pointer to y, I could have just said asterisk y pointer equals y, but I was very explicit right here, and I said asterisk y pointer equals address of y element 0, 0. I intentionally kind of made that very explicit for you so that there was no confusion. It says draw the memory allocation and give the value for each reference below, because I am using the dereference operator here, the asterisk. So first let's just draw the memory allocation. I think I'll get a pen here. Not that one. Pen. Pick a color. I like a color. So 2 rows, 4 columns. This is first row. This is second row. Column 1, column 2, column 3, column 4. So this is y element 0, 0. This one is, and rather than writing all the brackets out, this is 0, 1, 0, 2, and 0, 3. This is 1, 0, 1, 1, 1, 2, and 1, 3. If I were to draw that out in memory, the memory allocation formally looks like this. Y 0, 0 gets 1. Y 0, 1 gets 8. I'll pause it for a minute and write all that in so I don't waste your time watching me write. Voila, magic. So here is the memory allocation. What's stored in y element 0, 0 is a 1. Go through sequentially. What's stored in y element 1, 3 is this 0, for example. So, okay, so we drew the memory allocation. Let's give the value for each reference below. So it says reference to, what does y pointer point to? Well, that's the initial address of the array. That's y 0, 0. So y 0, 0 points to a 1. So we get this equals 1. Easily enough. Now, this number 2 is showing an offset. So I have what's pointing to y pointer plus 2, and this 2 is considered an offset. So what's pointing to y pointer with an offset of 2 here's y pointer, and we offset 2, 1, 2, and it's pointing to 7. Offset, 2 is an offset. Number 3 is a different problem. It says the thing pointing to by y pointer plus 2. So y pointer points to the initial address of the array up here, and it's pointing to the number 1. So it's saying, what's 1 plus 2? And so that answer is 3. So it's very different when the parentheses are not there. Let's look at number 4. This says the thing pointed to by y pointer plus an offset. Here we go again. This is the offset because it's in the parentheses. So y pointer is here, the beginning of the array, but the offset is 1. So it's pointing to an 8. Plus, here's y pointer with an offset of 3. I have the parentheses again, so there's an offset. So offset of 3, 1, 2, 3, it's a 6. Whoops, 6. So the answer is 14. Let's give a even more interesting example next. Actually, before I go on to the my next interesting example, this example that I just did right now, you need to be very familiar with that to do the homework problem, the first homework problem. It's not particularly a difficult homework problem because it's not a huge program, but it is using this concept quite a bit just for you to demo adding up things in an array by using pointers. But this problem right here is the key. This example right here is the key to doing that homework problem number 1 that I've given you. My next example here, I've declared a 2D array called board, kind of like maybe thinking about a checkerboard in the future here, or yeah, tic-tac-toe board maybe in your future. But anyway, I've declared a thing called board, and I assigned a number to each one of the positions. It's 3 by 3. And I'm just going to highlight some of this addressing thing that I just talked about in offsets. So if I print the address of the board, and I just said board, that is the name of the array, and I put a %p format specifier there, so I get an address in hex. So that will give you the address. There's the answer right there. The next one I said print the address of board element 00. So here it is, address of board element 00, print it as an address, and I get the same value, right? Because the address of the array is the same as the address of the first element. And then the last thing I did is say print board element 0. You said this is 2 by 2. What does that mean exactly? But I get the same address. I'm going to explain what that means in just a moment. I've actually asked for 3 different things in this program. One, I've asked for the address of the array. One, I've asked for the address of the first element in the array. And in the third option, I've asked for the address of one of the subarrays, because basically a 2D array is notionally an array of 1D arrays. So let's look a little bit more at this problem. Same board example. Now, instead of asking for addresses, I'm going to ask for the values of these same things, or similar things. The value of board element 00 is a 1. Okay, that's pretty straightforward. When I ask for the thing pointed to by, what am I pointing to? Board element 0, I get a 1. And right here I've used a double asterisk because this is a 2D array. And I again get the answer of being the thing that I'm pointing to being a 1. So this is, I've asked for element 00. This I've asked for the thing pointed to at the beginning of a subarray. And this I've asked for the thing pointed to specifically to the first element again, but I'm pointing to it instead. So a 2D array is, like I said, notionally an array of 1D arrays. So each row is a 1D array, right? And I put them together sequentially. So when I'm asking in the 2D array, when I'm asking for an array name, I can just say board. But if I ask for board 0, I'm actually asking for the address of one of the subarrays, so one of the rows basically. And so these are very different things that give you the same answer, but they are not the same thing. So I'm going to do this next practice problem with you. This is a really nice example I borrowed from the textbook I used last semester, which was Engineering Problem Solving with C by Dolores Etter, E-T-T-E-R. And it's a practice problem from her textbook, and I really like it, so let's go over it. So it says consider the references to the switch2 function, and I've repeated the switch2 function right here, which looks exactly like the function I called swap in the last YouTube I made. It's just now got a different name. You have these 6 different usages of the function, and some of them are valid and some of them are not valid. So explain why a particular reference is invalid, and then for the valid references, give the memory snapshot before and after probably the function call. So number 1, it says I'm going to declare x and y as floats, and then I'm going to make my pointer definitions right here, and then I'm going to call the function, the switch function, to switch x and y. Is this one valid or not valid? Look at it for a moment. I give you a moment. And then I'll tell you the answer. So the answer is not valid, but why? Why is it not valid? It's not valid because wrong data type. If you look at my switch2 function that I've declared, it's expecting a pointer to an integer. So I cannot use this function if my values are floats. So good example. I like this example. I like this whole practice problem. Okay, so that's why that one's not valid. Let's look at the second one. Int, I have 2 ints declared. I have 2 pointers declared. Pointers to the addresses of these ints, f and g. And then I call the function. Is it valid or not valid? The answer in this one is valid. All right. Number 2 is valid. Number 3. Int f equals 2, g equals 7. Declare some pointers to those variables, and then call the function. Is it valid or not valid? Not valid. Why is it not valid? It's not valid because we're not passing an address. Got to pass an address. See up here, we're passing an address. Oops. This one we're passing an address. This was not valid for a different reason. If we look at the valid example, we're passing an address. Can't pass this to it. This is not an address. It's a variable who is storing an address as its value, but it's not an address. Number 4, declare ints, declare pointers to the address, and then call the function. Is that valid or not valid? Not valid. Why? It's not valid because why do I want to pass the address of the pointer? I don't want the address of the pointer. I want the thing that I'm pointing to, F and G, not the address of the pointer. Anyway, okay. Number 5. Let's look at number 5. This looks pretty good. Int F and G, pointers to addresses. Call the function. Is it valid or not valid? Valid. Why is it valid? Because I'm passing an address of a variable to the switch function. That's okay. I'm expecting to get an address of the thing I want to switch, and I'm getting an address. So it is valid. Number 6. Valid or not valid? Not valid. Why is it not valid? It's not valid because I'm actually trying to do a pass by value instead of a pass by reference here, basically. So I'm trying to send the variables the value of variables f and g into a function that's expecting to have an address passed to it. So that makes it not valid.